Hello everyone, this is a video lesson for Unit 432 in our probability unit. Today's topic we will be focusing on the multiplication rule, and as you can see this is going to be our agenda for today's video lesson. Here is a warm-up. As you can see, I have allotted 5 minutes for you to try the warm-up. It may take you less time, and I am not going to start the timer because you can simply pause it and try the warm-up yourself. Yet, just some advice as you are going through the lesson, and in particular this warm-up, it never hurts to kind of highlight some important words as you're reading through the problem. As you can see, what I highlighted in pink, if they approve of their service, that is kind of a key phrase indicating that we should probably use conditional probability. As for warm-up problem number 2, hopefully you have created the sample space already, since we've kind of seen this situation before, tossing a coin 3 times. Here are the answers to the warm-up. So as you can see, for the first warm-up problem, I simply used the conditional probability equation, giving us an answer of 91%. As for warm-up problem number 2, I have created the sample space for you over here off to the lower right corner. And I have set up the problem, and as you can see, both of the probabilities happen to be 1/4 or 25%. Hope you did well on that. All right, so here are just the worked out homework solutions from the previous day's homework. Friendly reminder, these answers are also in the back of your workbook, so hopefully you are checking your answers. Now, depending on your teacher, you may or may not have had to prove whether something is independent or not, but you for sure should have had to do the comparison. So hopefully you indicated which conditional probability is greater than the other. Here are some more worked out homework solutions. Notice in the table, I hope you were able to come up with your totals. Friendly reminder, as you add these totals up horizontally, it should equal 150. Likewise, as you add up the totals vertically, that too should total 150. Again, how are you doing with the comparisons? Okay, here are some other answers, and here's a few more seconds for you to check the work. Of course, if you have any questions, stop by Math Resource or go and meet with your teacher. All right, I think let's move on. As I mentioned before, we are focusing on the multiplication rule. So hopefully by the end of class today, you will be able to define and apply the multiplication rule in order to find probabilities of different events. All right, so on page 77 is another warm-up. This warm-up is from the workbook. Go ahead, take a few seconds, locate the chart on page 77, try to understand it. And if you read the different questions below the table, you are actually simply doing some simple probability. All right, so what's the probability that the student is male? Well, let's look at our list, count them up. Friendly reminder, right? Probability is what we want over the total. So in this case, the probability that the student selected is male. Well, there seems to be 6 male students out of a total of 14 students. Yes, you can certainly reduce that to 3/7, which is giving us approximately 42.9%. Part 2 is asking for the probability of female students. And looks like we have 8 female students out of the total of 14 students. That, why not reduce it? And this is going to give us approximately a 57.1% probability of selecting a female student. As for part 3 of the warm-up, which is more likely to be selected, you can see that from the percentages as well as the fractions. It is more likely to select a female student. Lastly, what is the probability that the student's name begins with the letter O? Sorry, not quite sure what the screen is doing. Sorry for bouncing around. So probability of selecting a student's name that begins with an O, there's simply 2 out of the 14. Again, let's reduce it, giving us a 1/7, which is about a 14.3% probability of selecting a student's name who begins with the letter O. Again, hope you did well, and let's move on. Okay, so page 78 should be blank in your workbook. Why don't you go ahead, write down the following. So by definition, the multiplication rule is defined as the probability of 2 events when A and B are independent. So when A and B are independent events, we can use the following formula. Please notice if A and B are dependent events, we should use the following formula towards the bottom of the screen. Let's talk about the dependent events. Okay? So by definition, an event is considered independent if its outcome does not influence the outcome of another event. Yet if something is dependent, look at what's going on in this formula. The probability of A and B is equal to the probability of event A and or times the probability of event B, given that event A happened, given that condition. So conceptually, I hope this formula for dependent events makes sense. All right, so going to page 79, you can see we have our first example. So the example is talking about Naveen, who bought some new clothes, bought some shirts and pants, and the color of each shirt and pant is indicated in the table. One thing I would like you guys to focus on in today's lesson is this whole idea of replacement versus without replacement. That really alters how you calculate the probability, and it really alters in determining if the event is going to be independent or dependent. Now, for this particular example, it is not really specified, so I went ahead and just kind of said, you know what, let's assume the piece of clothing is selected and then replaced. So this is going to be an example with replacement. In part 1, it is asking us to use some probability notation. So I'm going to use SB, and I'm going to indicate that is going to be that a shirt is selected, that a shirt is blue. Then I'm going to call event PB to indicate that the pant is blue. So that's the notation that I'm going to use. And you know what? Let's keep to the theme. Let's make it blue. Alrighty. Okay, let's talk about part 2. So if you notice, looking at the table, we actually only have one pair of pants that is blue. We also only have one shirt that is blue. Because of that, I will explain, but the events are actually going to be independent. Here's the reasoning behind that. If I select a blue shirt, is the probability of selecting another blue shirt going to change? Not really, because I only have one blue shirt. Likewise, if I select a blue pant, a blue pair of pants, because that is the only pair of blue pants, selecting that will not alter the probability for the next event, especially if what I'm focusing on right now is selecting a blue shirt or a blue pair of pants. So conceptually, for that reason, we are going to identify events SB and PB as independent. Having said that, let's go ahead and calculate the probability for each event. So now the fact that I have decided and explained to you guys that the probability is going to be independent events, that is why I am going to use the following formula. And let's match this formula to look like, or let's match this formula to look like the events that we have identified. So real quickly, the probability of selecting a blue shirt or a shirt that is blue is simply going to be 1 out of the 7 pieces of clothing. The probability of selecting a pair of pants that is blue, whoops, there goes that. There goes that stylus pen. Let's try that again. So the probability of selecting a pair of pants that is blue, and again I said let's consider this as with replacement, so I selected the blue shirt and put it back should now be 1/7 as well. All right, so here's our multiplication rule. And let's use and change it so that it is using the notation that we are using. Okay, so now let's just do some substitution. Giving us 1/49. Let me try that again, which is going to be approximately 2 4/4%. So that's going to be our probability of selecting a shirt that is blue and a pair of pants that is blue.